Hello students, welcome to M10 classes. Hope you all are doing well. During this lockdown, you are getting a golden opportunity to learn all your lessons and revise them as you are getting a lot of time to do so. In the previous lecture, we had read about Ohm's law, resistance, the factor affecting resistance, and the combination of resistances that is in parallel and series. So today we are going to solve numericals on the basis of the portions that we have read in the previous lecture. So in the previous lecture I had given you some homeworks. I don't know whether you have done it or not, but as I have told you, I am going to discuss all those numericals here in this video. Now let us start with the first question. Which do you think has more resistance, a thin wire or a thick wire of same length and of same material? Now first of all, from the question, let us see what is the difference between a thin wire and a thick wire. The length is already given same and the materials are same. So in a thin wire and a thick wire, in case of a thin wire the area of cross section is less, whereas in case of thick wire the area of cross section is more. Now let us see what is their relation with resistance. Okay, as you know that resistance is inversely proportional to the area of cross section. Now that means if the area is less, the resistance will be more. So in case of thin wire, the area of cross section is less, and that is why the resistance will be more. So the thin wire will have more resistance. Coming to the second question, if a wire of resistance R is divided into two parts and then connected in parallel, then what will be the new resistance? So go according to the question. What is the data given to you? There is a wire that has resistance R. So I had shown you a wire here whose resistance is R, and it is divided into two parts equally, and that means the resistance will also be divided equally, that is R by 2 and R by 2. Now next, here they are connected in parallel. So as they are connected in parallel, we are going to use the formula 1 by R equals to 1 by R1 and 1 plus 1 by R2. So let us put the values. You will get 1 by Rp equals to 4 by R. But it is the value of 1 by Rp. To get the value of Rp, we have to get the reciprocal of it, and we will get Rp equals to R by 4. So what will you write? You will write the answer. What your conclusion will be, the new resistance will be 1/4 that of the original value. Now let us discuss the next question. If a length of the wire is increased by 4 times and the diameter is increased by 2 times, then how will the resistance change? Okay, now first of all, previously there was a resistance, there is a wire that had particular resistance. So for that wire, let's say the resistance is R, length is L, diameter is D, and the radius is R. Now so what will be the relation? That means the resistance R equals to rho L by A. So here you are getting A. Area means area of cross section, whose value is pi r square, because the area of cross section of a wire is nothing but a circle. So it is pi r square, and that is why you are taken the resistance. Now in the next case, what happens? The length is increased by 4 times. Okay, so let the new resistance will be R1. Length is 4 times that of original length. So L1, let's say the new length will be 4 times of that of original length, that is 4L. New diameter D1, that is twice that of, it is increased by 2 times, so D1 equals to 2D. But to get the area, we need to get the resistance, and diameter, as you know, is twice of the radius. Now putting the value, you will get R1 equals to 2R. So what is the next thing to do? We have to find the resistance, new resistance. Okay, so before that we'll find A1, the area. Area is pi R1 square. Put the value of R1, that is equals to 2R. From that you'll get, it is 4 into pi R square, and that is nothing but 4A. That means the area is increased by how many times? 4 times. Now put it in the formula R1. R1 equals to, similar it will be rho L1 by A1. Okay. Now what will happen? Put the values of L1, that is 4L, A1 as equals to 4A, and it will be cancelled out. We will get resistance R. That means after increasing the length by 4 times and increasing the diameter by 2 times, still the resistance will remain same. This is the conclusion. Coming to the fourth question, and this is a good question and an important question. Now see here, a wire of resistance R is melted and recasted into a wire whose length becomes twice. Find the new resistance. So as we have taken in the previous question that let the resistance be R, length be L and area be A. And for the new recasted wire, let the resistance be R1, length L1 and area A1. And as per the data given, that means the length becomes twice, so L1 equals to 2L. Now students see here. Here it is given, it is melted and recasted. So you might have already read problems related to volumes in class 8 and in class 9th also. So when it is melted and recasted, its volume remains same. That means if the length has changed, that means its area might have also changed. So for that we need to compare the volumes. Now a wire is in the form of a cylinder, and for the cylinder, what is the formula of your volume? It is pi r square h, but I have written it here AL. Why is it so? Because the area of cross section of a cylinder is circle, that is pi r square. So in place of pi r square it is A, and for the height of the cylinder in case of the wire it is nothing but the length, so I have written it AL. Now if the volume remains same, you can write A1 L1 equals to A into L, as the volume remains same. Now put the value of L1, it has increased by 2 times. Now put the value of L1 as 2L, you'll get A1 equals to A by 2. Now you have got the variation in length as well as in area. Now let us find the new resistance. So R1 equals to rho L1 by A1, put their values. You'll get it is 4R. That means when it is melted and recasted, its length becomes twice and the area of cross section decreases. And both of the factors, they increase the resistance, and that is why the resistance has become how many times? 4 times. This is a good question. Now in the homework question, in the question number 5, I have given a question, write the factors on which resistivity depends. So resistivity depends upon the nature of the material, whether it is a metal or a metalloid or an insulator. In case of metal, the resistivity is very less, and in case of insulators is very high. And what is the other factor? The other factor is temperature. Resistivity also depends upon temperature. Now in the next questions I am going to solve the problems related to the combination of resistors, that means for parallel and series. Now let us see some of the examples how to find which are in parallel and which are in series. I am giving you some examples. After that we are going to solve numericals. Now let us see. Now let's say there are 3 resistances, and how to know that which are in series and which are in parallel. Let's say it's resistance 1, it's resistance 2, it's resistance 3. I have told you, you have to take, like in case of a fish, take head, tail, head, tail. Okay. Now let's say for this resistance, current flows in this direction. This is H, this is T, this is H, this is T, this is H, and this is T. Now for this 1 and 2 resistor, see, these two heads at our one end and these two tails, it is at one end. So this is head end, this is tail end. So these two are in parallel. But what about the third one? See, since this total is in parallel, I will get a equivalent resistance for this, which has head here and tail here, and again the sequence is head, tail, tail. So this is the sequence. It will give you the series connection, head, tail, mundalanja, mundalanja. It is series connection. If heads are at one end, tails are at one end, that means mundas are at one end, lanjas are at one end. This is called parallel connection. This is one example. Now let's see another example. Okay, for this head tail I am going to use circle and crosses, let's say. Okay, now let us say the current flows in this direction, so it will flow in this direction like this. So for this one, this is head, this is tail, this is head, this is tail, this is head, and this is tail. So now here, see here, so this 1 and 2, this is in the format head tail head tail. So these two are in series, head tail. But see here, for this is head, this is head, so this is the head end, this is tail, this is tail, so this is the tail end. That means heads are at one end, tail at one end. That means this total resistance with 3 is in parallel, because heads are at one end and tail at other end. So this is in parallel. Okay. Now these are some examples. Now let us start with some questions. Find the resistance in the following combinations. Let us first start from 1. Okay. Now see, all these 5 resistors seem to be like in parallel, but you have to put this head tail logic. Now see here, it would be head tail head tail head tail. So you can see here, this is in head tail series. That means it is in series connection. They are looking like they are in parallel, but all these are in series connection. So in series connection, the total resistance is the sum of all the resistances. So you are going to get 5R, sum of all the R's. Okay. Now coming to the next question, there are 3 resistors, that is 10, 20 and 30. So they all are in parallel, as you can see. So 1 by Rp equals to 1 by 10, 1 by 20 plus 1 by 30. Oh no, no, it's wrong. Now see here, in case when there is a there is a 30 ohm resistor, there you have a plug key, but it is open. Now if it is open, current will not pass through this. That means this resistor will not be accounted while calculating the total resistance. So which two resistors will be taken into account? That is nothing but 10 and 20, and they are in parallel. So put the formula of parallel connection, will get the answer. Okay. Now coming to the third question, 40, 40, 40, 40, 440 ohm resistances are there, but still the resistance is 0 ohm. Now you might be thinking that sir is making some joke here. Now see here, in between A and B there is a short circuit. That means in this, through this point there is no resistor. And you know, everybody wants to go in a free path. Then why should the current go through the resistive path, as there is a conductive path? So when there is no resistor between 2 points, so and there is a conductor here, conducting wire, so this is short circuited and the current will not pass through this resistors, and that is why the resistance should be 0. Now next question, see here, question number 4. Now put the head tail logic. This 3 ohm and 2 ohm, they are in series, head tail. So they are in series, so 3 plus type 2, they will get 5 ohm. So this R a series resistance. First of all, you have got 5 ohm, and this total 2 are in parallel with 10 ohm. So that is why 1 by Rp equals to 1 by Rs plus 1 by 10, and you will get the total equivalent resistance over here. Students, just go through these questions again. Also, if you have any problem here, go through the questions, and if you have any doubt, you'll write in the comment section. Now here there are 2 questions again related to the combination of resistors. One is from your example of your book, and another question that I have given over here. Now in the first question, as you can see, R1 and R2, they are in parallel. So I will get first resistance in parallel, equivalent resistance 1 by Rp1 equals to 1 by R1 plus 1 by R2. I am getting 1 by Rp1 equals to 1 by 8. So taking the reciprocal, Rp equals to 8 ohm. Now secondly, here in this case, you have 3 resistors in parallel. Again, if they are connected in parallel, for their equivalent resistance, let be Rp. So 1 by Rp2 equals to 1 by R3, 1 by R4 and 1 by R5. So getting that Rp equals to 10 ohm. Now see here, this is head, this is tail, this is head, this is tail, because the current is flowing in this direction. So this is in series, head tail logic. So this RP1 and RP2 are in series, and that is why we are going to get RS equals to RP1 plus RP2, that is equals to 18 ohm. And here it is also given that find the current in 1. So in this question, bit number 1, you have voltage equals to 12 volt, the voltage source. The resistance you have got is 18 ohm. So you have to divide, that is using Ohm's law, I equals to V by R. You are going to get the current here. Now for the bit number 2, just look at this circuit carefully, okay, and whatever I am saying, just have to concentrate over this. Now see here, 3 resistors are there, A within AB, BC and CD, but there is a connection between A to C and B to D. Students, always listen that if in between 2 points there is no resistor, then consider that both the points are same. Okay, I'm telling you again, if in between 2 points there are no resistor and they are connected through a wire, consider them as the same point. Okay, now we have to find between X and Y. Okay, so taken here X and Y. Now see here, between, first let's say take A and B. Okay, so I have taken A here and B here, and in between A and B you have 6 ohm. So let's say this is the 6 ohm resistance. Okay, now see here, in between A and C there is a conducting path. Okay, this one, if there is a conducting path, I'll consider A and C are same points, so I have taken C here. Again, in between B and D there is a conducting path over here, so I'll consider B and D at the same points. So what next? Just arrange the resistors. Between A and B we have already taken the 6 ohm resistor. Between B and C there is also a 6 ohm resistor. Now see here, B, there is B here, this is C, so between B and C let's say 6 ohm again. Between C and D again 6 ohm, put here C and D 6 ohm. So as per the arrangement we have seen here, all the 3 resistors are in parallel. So in parallel combination you can easily find out the resistance. 1 by Rp equals to 1 by R1 plus 1 by R2 plus 1 by R3, and you will get this answer. Okay, now let us come to the last question of this video. How would you connect 3 resistors each of resistance 6 ohm so that the resulting combination has a resistance of 9 ohm and 4 ohm? This is a question from a book also. Okay, now listen carefully. First of all, I have told you, during in case of series combination the total resistance is greater than each individual resistance. In case of parallel combination the total resistance is less than each individual resistance. Okay, now let's take the first case. In the first case you need to get 9 ohm, and 9 ohm is greater than 6 ohm resistor. That means that 6 ohm resistor must be in series with someone, because you need to get a greater value that must be in series. So first of all let us take a 6 ohm resistor here. So as you had 3 resistors, out of which one is already given in series, so the rest of 2 can be arranged in series or parallel. But in series, if they are going to be arranged, it will be 6 plus 6 plus 6, that is 18. So you have only one way to arrange them, that is in parallel. So let us arrange this 6 ohm and 6 ohm in parallel. Okay, now from the 6 ohm and 6 ohm which are in parallel, I will get the equivalent resistance as 3 ohm, and 6 ohm is connected in series, so 6 plus 3 you are getting it as 9 ohm. Okay, now coming to the next second bit, that means you need to get 4 ohm. As I have told you that in case of parallel only you can get a resistance which is less than each individual resistance. That means that 6 ohm must be in parallel with someone. So first let's say this 6 ohm resistor, this is in parallel with something. Okay, that means 2 more resistors left, Again, that they can be connected in parallel or series. If they will be connected in parallel, all the 6 resistors in parallel, the equivalent resistors will be R by N, 6 by 3, that is equals to 2. Will not get the value. So they can be only be arranged in series. Now let us see if they are arranged in series, what happens. Now when this both 6 ohms are connected in series, these two, the total resistance in series will be 12 ohm. Now getting to the equivalent resistance in parallel, 1 by Rp equals to 1 by Rs1 plus 1 by R3, you'll get Rp equals to 4 ohm. So this is the way you are going to find how to arrange the resistor. There are many more questions in this book also, as well as in different reference books also. And students, in this lecture, if you have any doubt, then please write it in the comment section. I'll get back to you. Okay students, in the next class we are going to read about electric heating effect of electric current, electric power, all these things. So till then students, go through the lessons in your book. As I have already told you, that each bit of your NCERT book is important. Read it carefully. If you have any doubt, get back to me, and I'll let you know the answer. Okay, with this, let us conclude this video. Thank you.